So welcome everybody. Welcome to the session, which is a how-to guide to security in the PAAS cloud. My name is John Field. I'm a security architect with Pivotal. And with me today is Shawn McKinney, a security architect with SciMass.
Head gopher.
Okay, so today we're going to talk about security in the PAAS cloud. And it's actually, I think, going to be an interesting talk. And the thing to keep in mind is that the purpose of this talk is to give you an overview. It's sort of a survey talk, an understanding of the issues surrounding security in the PAAS cloud and how to think about security. We're going to, of course, have code samples and demos. But the takeaway from this talk, if anything, is going to be the patterns of security and how to recognize stuff. Understand the requirements and how to recognize the right pattern. And then you can go and get the solution to that pattern and apply it. So let's dive right in. A couple of years ago, it was 2010, I guess, Carlos Bueno of Facebook kind of made a big splash with this statement, the conversation around the notion of being a full stack developer. And the idea being that no one can know everything about everything, but your goal as a developer should be that you understand what the application is doing, and you have some way of a mental picture, you can visualize what's happening up and down the stack as your application does its thing. And I think that's a wonderful thing. That's an expectation we should all have. But Shawn and I take it a little bit farther and say, well, be a full security stack developer. And in order to do security right, there's only one way to do it, which is to be a full stack security developer. It doesn't make sense to do security well in one space, but not really understand what's happening somewhere else. Right? That's not a part of the system I fully understand. That's not an area of the stack I'm comfortable with, so I don't really understand the security in that spot. That's really not a good answer. Right? So our goal for today is to get you to think like a full stack security developer and understand the security of your deployment from end to end. That's going to be our goal. Okay, so this leads to the question, people are not full stack security developers. Why is that? Why is it that people do not have that level of strength across the entire stack? And there's a couple of reasons for that. Fundamentally, security is pretty hard to do. Security is the first thing that's left out of most programming examples. If you're learning a new framework, if you're learning a new language, the first thing that is not included in that example is going to be the security aspects. So makes sense. When you go to look for security examples, if you find them, they're often trivial. The other thing is that when security is done right, it's orthogonal to the business use case. And so again, it's usually something, if you're doing it correctly, which is configuration driven, it's part of the framework that you're using, like the Spring Framework security. And when you do that, you're not putting that security into the area of the code where many of developers will see it. The majority of developers won't look at that code. Security architecture patterns themselves often look similar. And so as we go through this, one of the things I'm going to try to do is kind of demystify OAuth 2, right? There's been a lot of talk about OAuth 2 this week, lots of great sessions on learning OAuth 2 at the code level. But on the other hand, we need to come up a level and understand that there are actually multiple patterns that are existing in that protocol. And we'll talk through some of that. It's important to be able to recognize when a protocol is being used, basically, how is that protocol being applied in this situation? And is it subtly different from another use of that protocol? Can happen in things like Kerberos as well. You look at Kerberos or a SAML token exchange or an OAuth token exchange. Many of these things look similar, but they differ in subtle and important ways. Testing security can be tricky, right? Because doing stubs and mocks is hard. Doing adequate testing in general is an important thing, but doing it with security is particularly hard because it's hard to fake security, right? If you're going to be doing things with a test cert that's not really validated, then that means that you're not really testing that part of the code. So often that's something that gets lost during a crunch to get something out the door, is that the security testing can be short-circuited. Implementation details are often different from one organization to another, so as much as I talk to you today about the things you should be doing, the reality is that you have to realize it within your own environment. And there are going to be differences from every organization. And so again, that's something that only you can handle. We can give you the tools, but you're going to have to make sure you've got the details right. Finally, a good security architecture composes patterns. I've talked about this a little bit, the idea that these things have been solved. You just have to be familiar with the pattern that exists and apply it properly, and you should be good to go. The challenge is knowing when you see one. Spot it in the wild, recognize quickly that that's a solved problem, and then be able to deploy the right solution using your favorite toolkit, whether that's Spring Security OAuth 2 or it's something else. The other thing to keep in mind is that these patterns often transcend an individual application. Let's take the simple example of SSO. When you look at an SSO solution, by definition, it is something that is not limited to a single application, right? And you're part of a larger deployment. And when you think about things like solving the problem of role-based access control with a separation of duties, by definition, a dynamic or a static separation of duties concern is about the session that the user has across multiple applications. And so solving a security problem for one application is only getting part of the picture. Finally, requirements are changing, right? Every time, every way you go, you're going to find that your requirements are changing, and it's difficult to be responsive in an environment where basically when you think it was settled, we're going to switch things up on you again. And one of the things you see with cloud native is that there's an expectation that things are more dynamic, especially in the security space, more dynamic than they used to be. So how do we solve this? How do we get through this? It's a tall order to try to give everybody this full security stack developer in just an hour and a half. So Shawn and I have come up with what we call our 3 easy steps. It's a 3-step plan to make you a security architect across the full stack. So quick and painless. Step 1, we're going to examine a realistic Java deployment, a Java application written at enterprise grade that can do all of the things that you need to do to have secure Java deployment on a Tomcat server, right? And that's existing technology. That's not cloud native. That's actually existing traditional deployment. But we're going to understand its design and implementation at the level that anyone here will be able to repeat that process and be familiar with every layer in the stack. Then we're going to take that application and we're going to forklift it into Cloud Foundry. And there's 2 good reasons to do that. And it's not necessarily because we really have to have that in Cloud Foundry. It's actually that you can learn a lot about Cloud Foundry security by forklifting in an existing application and figuring out and understanding what has to change to make that happen. And that will highlight for you, as a full stack security developer, the things you need to be expert with when you're working in the Cloud Foundry space. And then finally, we'll take that existing app and we're going to extend it. And we're going to add in improved integration via the cloud native protocols that we'd like to see used. So you take that existing deployment and then say, okay, I want to participate, even though I'm forklifted into the cloud, I want to participate with other things that are executing that are cloud native. And that ability to do this heterogeneous coexistence, I think, is key. Because again, cloud native is great, and I'm all for starting fresh and we can be cloud native tomorrow. The problem is you've got existing investment installed base, and we have to interoperate securely with what's already there. So that'll be a lot of what we talk about. Everything we talk about here is going to be examples from real-world customer scenarios. Shawn and I have spent a lot of time in the last couple of years actually working with enterprise customers. And so we'll cut through 5 examples in total, and each one of them is going to be based on a sample application, which is a cut down of a real-world problem that we had to solve. Okay, so we're going to start. Everybody ready for the 3-step plan? Step 1, we're going to build a secure Java application. And as we do that, Shawn is going to take you through every step of it on how you get through the layers of the onion in your defense in depth. To start off, we're going to do a quick demo of that application so that you can get an idea of what it is we're looking at.
Thanks, John. Hello, everybody. It's a pleasure to be here today speaking to you. I know it's late in the day, and we're day 3 in the conference, and probably we're starting to get a little bit tired, if you're anything like me. This is a diagram of the application that we're going to be looking at, and it's called the Apache Fortress demo. And so before we even do anything further, I want to just go ahead and pull that thing up. It's running inside of an IaaS cloud currently. And so I'm going to go ahead and sign in as a user that is Uber. They have access to, and you can see the format of the app's pretty simple. This application has 3 pages, page 1, page 2, page 3, and then there's some customer data inside of there. And so this particular user, super user, has access to everything. They have access to all pages and all customers. Yeah.
So it's important to point out that the purpose of the app is to show you a problem in role-based access control. So it's 3 pages, there are 3 users, there's a matrix of access of who has access to what, and users have the ability to activate or deactivate a current role. So in the top half of that screen, you've got the ability to activate a role to do some function, and then you can deactivate the role at will. And it's not allowed to have certain roles activated at the same time, right? So the top half is like metadata, and that's kind of your peek inside the operation of the app. The bottom half is the business data, and you'll see whether the function is allowed to work based on the user's permission.
And the application's purely to demonstrate security.
Yeah.
And so anyway, thanks, John. This user is Uber, which means they have all pages, all customers, and we're going to say that that's an anti-pattern, right? That's in violation of, we've given that user too much power, all right? So anyway, that's kind of a sneak peek of the app that we're going to be talking about. And so this is an architectural diagram of the application. And over here to the right, we have all the things that we're going to do. And over here to the left is where everything happens at. So it's the layers in which everything occurs. And at the bottom here, you can see there's a link to the tutorial that's available online. Everything I'm going to show you is available. It's open source. It's freely available. So the tutorial has a complete step-by-step guide in which to follow if you want to try this at home. I'm not going to go through the step-by-steps here because my goal is for you to have a conceptual idea of what comprises a secure application as opposed to telling you how to set this thing up where there's the instructions. Okay, so that's our goal. And as I describe this application, I'm going to examine some themes that will hopefully explain the rationale for why we made the decisions we did. The first one is simplicity. So all of the controls that we're picking here, that we're using, are all really simple to use. Okay, that's not to say they're easy to use. So it's digging a ditch is simple, but it's not easy, right? It requires effort. And so the same's true of security. It requires effort. We tried to follow common sense when we applied controls in a particular area. So if it made sense from a common sense perspective, we went ahead and did it. And then the last theme is I'm going to use household analogies to explain to you the rationale of why these things are being done. Okay, so this is our sandbox. We're all presumably Java developers, and these are the layers in which we can operate in. There are specifically 5 layers of this application that we're interested in. The first layer is Java Secure Socket Extension. That's where confidentiality controls are applied. The second layer is Java EE Security. We're going to use that for authentication and coarse-grained authorization. The third layer is Spring Security, which can do quite a lot, but in this particular demo, we're going to use it for medium-grained authorization or specifically page-level authorization. The fourth layer is the Web App Framework. We're starting to get deep down into it, and that's a finer grain level of authorization there. And finally, the fifth layer is the database, and that's the deepest and the most finest grain. As far as the rationale, with JSSE, that is confidentiality. So you think about why you'd want to be confidential. Think of a real-world scenario where you're talking to a loved one, and you're talking about something that's sensitive or important. You're going to lower your voice so that it can't be overheard, right? Because you care about that person, and you don't want harm to come to them. Well, the same's true in a web application. We care about our users. We care about our service providers, so we ought to encrypt that traffic. So Rob Winch, I don't know how many of you guys went to his talk last night. It was an excellent talk. He made the case for me. HTTPS everywhere. Just use it. Don't think about it. Use it and test. Use it. Just forget about even asking the question if you should do it. Yes, you should. Okay? The second layer is Java EE Security. That's the deadbolt on the front door. So you think about in the home, the first level of defense you have is a deadbolt, right? You don't make a deadbolt. You go out and you buy it and you use it. You don't even think about it. You walk in the house, you turn the deadbolt, and that's because you want to keep everything safe. So Java EE Security in the web app is the deadbolt. Okay? The third layer is Spring. Once you're in the house, you've gotten past the deadbolt, what rooms can you go in? Common sense would dictate that you have a way in which to lock the doors on rooms, right? You've got small children. There might be things that you're worried about. You want to be able to lock the doors. The same's true in a web app. You need to have a way in which to lock the doors on the web app. That's the pages of the app, okay? The fourth layer is the web app framework. We're getting deeper down in there. Once you can go inside of the room, what can you do? What equipment can you operate? Can you turn on the TV set? Can you operate the furnace? Can you turn on the stove? Common sense would dictate that you have a way in which to control that. The same's true in a web app, and the web app framework's how we're going to do it today. The fifth layer is the database, okay? We're down in the deepest layer. That's the finest level of granularity. That's where you filter the content. So back to our house, we're able to get into a room, say it's a living room, there's a TV set, we can turn on the TV set. What channels can you watch? Is there a way in which to control that? Do you have children in the house? Common sense would dictate if you did, you'd have a way in which to filter that content. The same is true in a web app. You should have a way in which to filter that content. Today, we're going to show you one way in which to do that. These are the two areas of access control that we're going to be focusing on. Area 1 is Java EE and Spring Role. That's a declarative level of access control. The second layer is role-based access control, permission-based semantics. We're going to be exercising programmatic permission-based invocations. Okay, so let's get started. This is, as John said, a Tomcat application, and so we're going to have the Tomcat servlet container engaged. And as I said before, just turn on HTTPS. Don't even think about it, do it. How do you do that? It's quite easy. You generate a key store, you import that key store into, or I'm sorry, you generate a private key, you import that into a key store, you make that available to Tomcat. I'm not going to tell you exactly all the steps. If you want to do it, if you're interested and you want to try it, just follow the steps in the tutorial. But it's just really easy to do. You ought to do it. Okay, while you're in there, while you're in the Tomcat server, go ahead and disable those weak Diffie-Hellman ciphers. And,
and while you're at it, turn off RC4 and MD5.
Okay, so we've got HTTPS turned on. Now we want to do Java EE security. Again, this is where authentication and coarse-grained authorization controls are done. This is the deadbolt, okay? So in this particular example, we are using the Fortress Tomcat realm, which is, I don't know how many of you guys have ever used Java EE security, but a realm is a way in which you can do a policy decision point with Tomcat. Okay, so again, this tutorial will take you through all the steps. This is really quite easy to do. You just drop a lib folder, or you drop a jar in the Tomcat lib folder, and then that particular realm proxy jar accesses the security systems the security systems implementation classes which reside inside the web apps jar or inside the web apps war file.
Right. There's a connection there to LDAP, so let's be clear because that's going to be important in the Cloud Foundry segment, that there's a connection to LDAP, and those jar files dropped into Tomcat allow Tomcat to connect to LDAP. That's
when it's doing a security call, it calls back to this, so it's
part of container-based authentication.
Right. Okay, so we're still in the enablement of Java EE security. The next thing we're going to do inside the web app, in the web.xml deployment descriptor, we're going to add a few declarations in there. The first one specifies a URL pattern of what's being secured. In this case, we're going to secure everything. The second thing you do is you specify the role that has access to that page. Again, we're doing coarse-grained authorization, so we're just going to say one role. There's one role. Every user, to hit that app, you have this application role. That's it. It's a deadbolt. Okay, and then the last thing we're going to do is we're going to specify that it's form-based authentication and where it's at, so that the container can log you in when it's time. All right, still in the app, the next thing we're going to do is tell the application to use the Tomcat realm. How you do that is you drop a context.xml file in the meta-inf folder of your application, and then that points back to the Fortress realm for the security checks. All right, so we've got Java EE authentication turned on. We need to do a little bit of work to get the policy decision point that's in use set up. And again, we are going to use the Apache Fortress system. And this slide tells you how to install it. And so back to the tutorial, there's a step-by-step guide. But basically, the Apache Directory Fortress role-based access control system is all open source. It's all freely available, and it's ready to use. And this thing will tell you how to do it. But the four components you have to install is a directory server, otherwise known as LDAP. You're going to install an LDAP browser, which is called the Directory Studio, and you're going to install two of the components for the policy decision point. Incidentally, I am the Fortress development lead, so that's a full disclosure. All right, so just bear that in mind.
Yeah. How many people have used or think that they could have a problem that could be solved by using role-based access control? Is that like true ANSI RBAC? Shawn's going to get to that. Why don't you go ahead, Shawn, talk about ANSI RBAC, and then we'll get there.
Okay, so we're still enabling the policy decision point.
Yeah.
And so we're back to the application. The next thing we're going to do is we're going to drop a declaration in the POM file that tells the application to use the Fortress dependencies. Next, we are going to, in the web.xml, we're going to drop another declaration in there to tell the application to use Spring, and then we're going to tell the application where the Spring context file is. And then inside the Spring context file, we're going to drop another declarative in there to tell the application to, or tell Spring to inject the Fortress Spring beans into the runtime so that the application can do programmatic invocations later. Okay, so a little bit about role-based access control. We're talking about the ANSI Insights 359 specification. So just because you use roles for access control doesn't mean it's role-based access control. Okay, so role-based access control is a specification, and it's very explicit about what it does. And so we're going to talk about some of that today. But the first thing is RBAC 0, that's the base, okay, and that is users, roles, permissions, and most importantly, sessions. And sessions is the context in which a role is made available to the user at runtime. And that's in keeping with the principle of least privilege. Just because a user has been assigned a role doesn't necessarily mean that it's going to be used, okay? All right, so RBAC 1 is hierarchical roles. And that's how you establish inheritance relationships between roles. And that's useful for administration. RBAC 2 is static separation of duties. And that's how you establish mutual exclusion constraints between assigned roles. And so an everyday scenario there of why you'd want to do that is back to the household. So say you have a member of the household who's a child, and you have another member of the household who's a parent. And you can never have a member of the household who's both. Static separation of duties is a way in which to enforce that constraint at administration time in the policy decision point. Okay, RBAC 3 is dynamic separation of duties. That's going to be our focus today, okay? And dynamic separation of duties is how you establish mutual exclusion constraints between activated roles. Now, why would you want to do that? So we're back to the household. We have a member of the household, and they are a teenager, and they may stay at home alone. That same member of the household may have a friend over. But that member of the household that's a teenager may never stay at home alone with a friend over. RBAC, dynamic separation of duties, is a way in which to enforce that constraint at runtime in the policy decision point. So again, we're going to demo that in just a minute and have a closer look at that. RBAC object model is very explicit about what's involved. There's 6 basic elements. We all know what a user is. Most of you probably know what a role is. A role is a many-to-many mapping between users and permissions. A permission is a mapping between an object, which is a runtime resource like a page or a file or a table, and an operation, which is an executable image of a program like add, update, delete, search. Okay, and then that combination's a permission, and that's what's granted to the role, and then the role is assigned to the user, and that's how the entitlements go across. I already talked a little bit about the session, but that's the context in which roles are activated. The RBAC functional model is the APIs, essentially, and there's 3 basic interfaces. And RBAC's very explicit about what those APIs look like and what they do. The first 2, admin and review, are for management and configuration processes. The third one, the system, is what we're going to focus on today. That's for runtime access control. And that's what we're going to be demoing here in just a second. So the system manager APIs are as follows. Create session is how you authenticate and activate roles. Check access is for a single permission check. Session permissions returns all permissions that have been activated in that session. And add and drop active role, or add and drop active roles is how you add and remove power to that session at runtime. And so we're going to look at that. Another thing we got to think about inside this application, remember we've got many layers. There's Java EE all the way down. So we need to have a way in which to propagate that identity across. Okay, so authentication's happening inside the container, and then authorization's happening inside the app. They're not directly connected. So how do you get that to flow down? And so in this case, we are using the servlet get principal API to return the principal to the application, and the application calls toString on that, which serializes it. And then the application calls a Fortress API to deserialize it into a proper RBAC session, which is then pushed into the HTTP session and made available for authorization later. Okay, so we've got, now we are down to trying to secure the directory. So we've got our RBAC policy decision point set up. Well, that is actually some classes that are talking to a directory that's on a remote server somewhere. And we're sending passwords and policies over the wire. Common sense would dictate that you would encrypt that. Don't think about it, just do it. So this application shows you how, and it's really very easy. You just import the public key that you generated in the first step into the Java key store, and then you add some properties to the config file to tell it where it is. On the server side, all we have to do is fire up the Apache Directory Studio, and we're going to import the key store that has the private key into the directory server, and we're going to restart the daemon. Okay, that's all we got to do there. All right, so we are now down inside the application. We have HTTPS, We've got the deadbolt on the front door. We've got the RBAC policy decision point set up. We've got SSL over the directory. It's now time to get in there and to secure the pages. So Spring's how we're going to do that. And that's really easy to do. We all love Spring. It's a fantastic facility. The Spring security is fantastic. So we're going to add a few more dependencies in our POM file. And then we're going to add some declaratives to our context, our Spring context file that basically tells the policy of the page to role mapping. Next, we are going to enable identity propagation from the container down into Spring because we got roles there. And so how we do that is we're going to turn on the Spring security pre-authenticated authentication filter. And then that's going to enable Spring to use the roles that are activated for the user from the Fortress realm.
Yeah, this is an important point because this is where we're saying the container and Tomcat and Fortress are doing the authentication, but we want Spring to pick that up and actually use that in the Spring security context. And that's the little magic bit right there.
Okay, so as far as role mapping, we also need to make the roles that the container activated available to Spring. We need to declare them, and so how you do that is you declare the role names in the web.xml. All right, so we're now down in the web app. We have authentication, authorization, coarse grain. We've got medium grain at the page. We've got SSL, and we haven't even woke the programmers up. Okay, they're still off in the corner. We don't know what they're doing yet, so we're going to wake them up now. It's time to engage the programmers. Okay, so we're now down in the web app, and we're going to start securing the controls that are on the page. So how we're going to do it in this, and there's 101 ways to skin the cat. Okay. So I'm not going to tell you how you need to do web app authorization. I'm just going to tell you you need to do it. And so I'm showing you an example of how it's done. In this case, we are using this application, Apache Fortress Demo, is an Apache Wicket web application. It uses the Wicket web app framework. This same technique would work with any of the frameworks. In this particular coding snippet, we have an example of a Wicket button, an AJAX button that has been overridden. And so I don't know what's going on with this pointer. Okay. Yeah, so that's the button that was overridden. We overrode that. And so basically what's going to happen there is if that user does not have a role that has that object, which is page one, and that operation, which is add, that button won't appear on the page. And so if the button does appear on the page, when they click on it, if that user does not have a role that has access to that customer number, in other words, we're now doing instance-based authorization, then it will fail. Okay, so that's an example of fine-grained authorization with instance data. All right, so we're now down, we've just done the web app framework. We're now down inside of the database. And so this is the deepest, darkest layer of the web application. This is where most programmers never go. We almost never do any kind of security on the database, right? Okay, so we're going to tell you that you should. All right, so how we chose to do it, this particular demo is using the MyBetis object relational mapping framework. This is just one example of how it could be done. You could use JPA, whatever, it doesn't matter. But in this particular case, we have an example of the data access object for page one. And you can see on the update, it's making a programmatic invocation into check access. And if that user does not have a role that has the object page one operation update and that particular customer number, that will throw a runtime exception and it will fail. All right, so we're almost done with the description or the overview. So we've got authorization all the way down the deepest layer, but we still got a problem. What is it? Well, we're communicating in our application with a database, and that's sending sensitive information over the wire remotely that has customer information. Common sense would dictate that you would encrypt that. Don't even think about it, just do it. So fortunately, it's real easy to do. In this particular application, we are using MySQL. And so with MySQL, all we got to do is add a string of characters to the end of the driver that tells it to use SSL, and then we're going to make the location of the trust store with the public key available to the runtime. On the server side, we're going to take the artifacts that we generated in step one, and we are going to make them available to MySQL by updating its config file, and then we're going to instruct the listener, the MySQL daemon, to listen to the host name that's in the certificate when it fires up. Okay, so that's what we did to the application. So now let's talk a little bit about the policy, and then we'll jump in. Okay, so this application, again, has 3 pages. It has some customer data. And then we have these roles that are from the page to customer mapping. So we got 3 pages, 3 customers. There's 9 roles. And then we set up a dynamic separation of duties constraint between each of those roles so that a user may have one and only one of those roles activated at a time. So I already showed you the super user at the beginning. He has the Uber role. He has access to everything. He's not subjected to dynamic separation of duties. I've got another user here called power user, and they have the same level of access, which is to say they've been assigned to every one of those roles, but they're going to be subjected to dynamic separation of duty constraints and can only have one of those roles activated at a time. And just for good measure, I've thrown in a few other users. There's user 1, 2, 3, and that user has access to all pages for a single customer. And then I've got user 1, and that has access to a single page for all customers. And then I have user 1, 1, 2, 3, and that user has access to a single page, single customer. So that's the policy. Let's go ahead and try it out with some of those users. So I'm going to go ahead and log in now as the power user. And so again, this user has access to all users, or I'm sorry, it has access to all pages, all customers. And so when they log in, it looks a lot like super user. There's all the links on the launch page. And so I can click on a link, and Spring is fine with letting them into that page, but there's no buttons at the bottom. Okay, why is it? Well, they have to activate a role first. So we have the list of roles over here on this control at the top of the screen that they can activate. So they're on page 1, so we could activate, say, page 1, 789, which is customer 789 for page 1. They activate that role. The buttons pop up at the bottom. Now I can interrogate or operate on that data for that particular customer, 789. So what if this user then tried to interrogate or activate data on another customer, say 456? We get an authorization error because that user hasn't activated that role yet. So let's just go ahead and activate that role. So I'm going to go in here and I'm going to drop down. I'm going to grab page 1, 456, and I'm going to hit activate. And now I got another exception. Well, why do I have another exception? That's a dynamic separation of duties constraint violation, which is saying that that user can only have one role activated in their session at a time. So before they can realize the role for customer 456 on page 1, they've got to deactivate the role that they had previously. So I'm going to go ahead and do that. I'm going to deactivate page 1789, and I'm going to activate page 1456, and then the buttons will pop back up for page 1, and then this user can then operate on that particular data.
Yeah, it's important to note that this is not going to happen without having a session, right? This is the concept of an RBAC session in that we know what applications are running. We know what activations are active right now. And you can't perform the dynamic separation of duties unless you are tracking that globally. So it's a capability that most applications don't usually use, but if you're in a regulated industry, banking, healthcare, this is something that there's no other way to do it if you don't have that session with the full RBAC compliance.
Okay, so we're going to now log in as user 1123. And user 1123 has access to all pages for a single customer. So you can see they've got all the links for all those different pages. But you look in the drop down, they only have one customer in there, so they can operate on 1, 2, 3. And so it's really the same as the power user. Only they're scoped down a little bit. And so you can see that, it's the same pattern. They've got activate, deactivate roles. And so there's, at this point, it's probably useful to point out that there's other constraints here. So you think about, well, what if this user tried to maybe sidestep the controls a little bit? You can see that in this drop down, the programmer, who was me, was actually kind of dumb, and they let them kind of key in a role name. So they're gonna go ahead and key in a role for another customer, and they try to activate it. Well, they can't because the RBAC policy decision point realizes that that role hasn't been assigned. So this is an example of security in depth, security across many layers. And so the security doesn't happen in just one layer, it happens across everything. So real quick, I'm gonna try another user here. We'll do, let's do, say, user 1. And you can see user 1 has access to one page for all customers, so there's all the customers there. I'm not going to go through the activation step again, but what if this user tried to sidestep the link, right? There's no link for page 2. Well, what if they tried to change that URL to page 2? So if they go up to the URL line and they change it to page 2, they can't do it because Spring security is engaged and Spring knows that they haven't been, that role's not activated, so they can't get in there. So once again, it's security across many layers. So the last user that I'm going to log in with is user 1123. This user is scoped to a single page, single customer. So when they go in, they've got one link. You can see they've got just one role in the drop down, and that's the only customer they can operate on. Okay, so that concludes the demo. Again, that particular application is available to you. You can go back to this slide. And incidentally, on these slides are hyperlinks to artifacts, and they're all live. So if you go back and look at it and click on it, you can look at this stuff in more detail.
Okay, great. Thanks, Shawn. So that's a Java web application that is completely secured top to bottom using well-understood technologies, but unfortunately, frequently people don't deploy it exactly right or choose to just not do it. So the benefit, of course, is having it all in one place. It really is a great how-to guide. And whenever you come across a question about how do I configure Tomcat or how do I configure for an RBAC session, you know, that is a perfectly great place to use as a reference. So kind of picking it up from there, the next step would be, okay, how do we do this in Cloud Foundry, right? Here's an existing application which is secure, soup to nuts, top to bottom. Can I run that in Cloud Foundry just the way it is? And it turns out we can run it in Cloud Foundry. It takes a little bit of work, but it's not as much as you might think. And we refer to that as being a forklifted application. I don't know if you've heard that phrase this week, but kind of all the rage. I realized that people started talking about forklifted, and I said to myself, oh, I've been actually doing that all along, trying to get applications into Cloud Foundry that weren't originally written for the cloud. It's not impossible to do. Again, we'd love to have cloud native all the way and start fresh, but if your existing app needs to be migrated, it is doable. Okay, let's see. Okay, so let's take a look. The same application. Now, I did this as a QuickTime movie because the truth is that I couldn't be sure that while we're standing here on stage, it would be easy to bring this up while it's running in the cloud. Have to get on a VPN and things like that. So rather than deal with that, you know, a quick movie that shows it. This is the Cloud Foundry operator console, the developer console. You can get in there. You see top of that list is the Fortress Apache demo. And if we click there, you can see that it's been up and running. And we have some bound services. And we can take a look at what the services are. Of course, we're bound to MySQL because this is a MySQL backend. And we've also bound a separate thing, which is the page 4 OAuth service. So this is a fourth page that I added to the application because we wanted to be able to do an additional data backend. So the second half of this is a demo of an application which is a backend JPA solution. It's written with Spring Data, Spring Boot, and basically offers up a RESTful data resource. And you can see that when we go to page 4, we can see data that's coming from this backend server. It's another tier in the integration. So the existing application had a MySQL service binding. And to mimic a real-world scenario of being able to get access to data which exists on a back-end service using Spring Data, surfacing as JSON REST, and be able to see that in the Apache Fortress demo. Now, to do that requires something called a client credentials grant in OAuth 2. So we'll come back to the slides. Okay. So how do we do this? This is all about forklifting an existing app, and then the third section is going to be about doing things in a more cloud-native way. When we talk about forklifting, there's one good reason to do this, which is you want to preserve the investment of your existing app, right? A lot of work went into writing this RBAC-compliant, fully regulated, compliant application. On the other hand, you also have this issue that the cloud security provided in Cloud Foundry is somewhat different than what you were using in your regular IaaS, where you owned and operate the entire infrastructure. So now that you're in the PAAS, the security architecture expectations are somewhat different, and as a result, there'll have to be some changes to the application. Truth is, it sounds worse than it is, right? The notion of forklifts come in more than one size, and sometimes it's a pretty small forklift. Other times it might be enormous. But in the case of this app, it turned out to be a perfectly doable task. So here's the to-do list. right? And I'm not going to take you through every detail of exactly how you do it, but I want to give you an overview of what's required when you move an existing application. Where are the points where you're going to have to actually allocate tasks to change things so that it will execute in Cloud Foundry? And number one on the list is that your TLS termination will be different, and you can read through that. There's 5 items, which is not really that long a list. It's basically 5 things that need to change. On the right-hand side here, we've got the aspect of Cloud Foundry that you need to understand in order to accomplish that task, right? In order to deal with the changes in TLS, you'll have to have an understanding of the Cloud Foundry security perimeter and the way we do request routing within the cloud. In order to understand how you deal with the differences in credential provisioning, you should have some understanding of how we do service bindings, right? So we can run through each of these. We'll do basically one slide on each one to take you through the process of what you'll need to do when you move an existing Java app over. So here's the existing app, just as Shawn left it to us. And what we're going to do is drop it into the PAAS cloud. And we're going to simplify it a little bit because we're all done talking about the internals of the app, right? Everything that happens within the WAR itself, that's not going to change. All of that will remain the same. And what we're talking about here is the change in the contract that the app has with the execution environment. Now, it's also probably true that LDAP is not running in the cloud, right? Because your existing infrastructure within your enterprise, LDAP was a pre-existing service long before the cloud came along. And it's probably still running just where it was before. So it's realistic to say that that's going to be an external service and not executing within the cloud. However, the database is a MySQL database, and that is absolutely something which can be a managed service within the cloud. So one of the advantages right off is that when you push your app into the cloud, you don't have to worry about setting up the MySQL database. So good news and bad news. We just taught you 13 steps on how to do a secure Java application deployment. And right off the bat, I'm going to tell you that half of those steps, you don't have to do them anymore, right? It's just not part of the problem.
You're saying it's easier.
It's either going to take, it's going to be compensating control that substitutes for the need to do that, or the cloud is going to do it for you.
How many here are using Foundry right now?
Okay, good number. We'll get more. Okay, so here's what it looks like when it's dropped into the cloud. Another layered onion picture, right? But this is what it actually looks like from an architecture perspective once your app has been pushed into the cloud. You've basically got that same WAR file, but the Java servlet container has been provided by the PAAS, right? You didn't have to set up your Tomcat server. You simply didn't do that. The cloud did it for you. On the other side, you've got the MySQL server, and similarly, that's been stood up for you. It's provided by the PAAS. All you had to do was say cf create service, and then bind your service to your application. And when you push your application, in other words, upload all of the code in the WAR file, you're going to get that connection dynamically created. And you're not going to need to worry about setting up the TLS inside the MySQL deployment. On the LDAP side, you have similar work to do. So let's go through each of these in turn. The TLS termination. TLS that today was going to terminate at the Tomcat server, and Shawn showed you how to configure Tomcat to do that. Instead, the TLS is going to be terminated at the cloud entry point. So there's a component at the front door of the cloud, which is an HA proxy, right, high availability proxy, and behind that sits the Cloud Foundry router. We're going to terminate the TLS session at the HA proxy. And so you'll have one certificate there for access into the cloud, and the browser will accept and trust that certificate. Of course, that can be issued by your enterprise. We'll have a self-signed certificate that comes out of the box. You're not going to use that in production. You're going to issue your own cert. But it'll be done for the front door to the entry point of the cloud. It's not going to be something you have to repeat for every application. The IP address and the port where the application is actually hosted as a droplet within a DEA or Diego cell, as a VM within the cloud, that IP address and the port are not visible beyond that router and HA proxy. Right? So you're going to set up your firewall rules so that anything that transits comes through that entry point, and the arbitrary port that we assign to that application is not visible outside of the deployment. On the credential provisioning, obviously you have to have an ID and password in order to get into the MySQL database. But instead of having to configure that manually, we're going to do that dynamically with a service binding. And so if we go back to that movie, and I won't do it right now, but if you go back to that movie and actually take a look at the description of the service binding in the Cloud Foundry Ops console, you see that the ID and password in the JDBC URL connection string are randomly generated username and password, which is dynamic, fully randomized, and it gets injected into your application at the point it's deployed and run. And it's not something you need to administer separately. So no provisioning, no hard-coded provisioning of JDBC database credentials within your application properties file or within your application context XML. Just don't need to do that anymore. Now, implications of this. Obviously, my feeling is that the database is more secure than it used to be, because the quality of that password and username are probably better than what you have today. On the downside, the challenge is that you may be complying with some audit report regime right now that says you have to produce me reports of all the usernames in the database and who they have access to. This is going to randomize your username. And so that's something to think about. On the one hand, maybe it makes your audit report more complicated. On the other hand, maybe it means we obviate the need for that audit report, right? And maybe have that conversation with your auditor. One more thing to note is that different people will have access to the password. It's no better, it's no worse. It's just that different people will have access to the password, because I can go into that operator's console as I'm checking on the status of the application. I can see the database credentials, right? On the other hand, the developer doesn't know them and can't know them because they're not even assigned until it gets into production. Okay, so the other big thing to think about is a build pack, right? So all of this work that you had to do for Tomcat, forget that. We're not doing it that way anymore. When you deploy your application within the cloud, you're doing that essentially by pushing the application and specifying the build pack, which is the runtime stack it's going to run with. Two things that matter. Shawn talked about the container realm and the trust store management. You got to have your public key certificates for the CAU trust in your Tomcat environment. And you've got to have your special jar file that connects you to that external LDAP server in your Tomcat environment. But you're not going to do it to Tomcat directly. The way you do this is you actually modify the Java build pack. And these are the commands you need. This is the exact command sequence that you'll need to do this. Basically, you're going to clone that build pack. It's a bunch of Java code with some extra bells and whistles. Those bells and whistles are part of the integration contract with the cloud. Basically, you're going to clone that, copy over the artifacts you need that are unique to your enterprise. Those will be things like your CA certificates or your lib files that belong in the Tomcat lib directory. Copy those over and rebuild the build pack. Not going to go through every step here, but when you're done, you get a zip file, and that enables you to upload the zip file into the cloud. And when you deploy an application, it gets deployed with that as the runtime stack. Okay? The last two lines there, you can see we're doing a Maven clean package. We build a new WAR file, and then finally push that application into the cloud, specifying the path to the new build, that WAR file output, and the path to the build pack. The name of the build pack that's available in the cloud. Build packs are meant to be used by a class of applications, not by a single application. So once you've done this and you've created a build pack that's valuable, you'll use that across all of your enterprise deployments. 3 ways to do a build pack. There's easy, expert, and offline. This is like a Maven build that's online or offline. You can either pull the bits down from the internet, you can pull the bits from a build pack service that's running within your enterprise, or you can do it strictly offline, where all of the bits that you're deploying with are static and don't change until you build another zip, right? So you have a lot better configuration control. Again, with our full security stack hat on, what's the implication? The trade-off between having better configuration control or always running with the latest and greatest. You need to find what that balance is based on whatever other controls you have, what other your DevOps procedures are within your enterprise. But individual developers don't do any container configuration for security, right? You're past the days of people having to modify Tomcat manually every time they deploy an application. Okay, last bit is the container isolation provided by Warden. Remember I said that these processes are executing within a VM that exists in the PAAS cloud, and within that VM we have multiple Warden containers which provide isolation at the Linux level, right? Little bit about that container isolation. The things that matter for now is to think about the fact that you have an isolated file system and you have an isolated view of the network. So at the end of the day, I like to say it's chroot on steroids. So if you've ever done chroot on a Linux system, you're basically saying this is the root of my file system. And that's what happens inside the Warden container. You're going to be running within a file system that is only there for you, and no one else is sharing your file system. Similarly, when you're on the network, there are IP tables rules executed in the kernel for the networking on that Linux server that basically controls your view of the network and gives you network isolation. When something comes through, and this is the picture that shows the Warden deployment, Tomcat runs in one Warden container, the MySQL server runs in another. Each one of these things has its own host name, it has a virtual NIC, it has what it believes to be a file system to itself, and it also has an IP address, right? There's IP tables rules so that when traffic comes into the host, things get routed to the appropriate container, and traffic that's coming to the Warden container A for Tomcat is not going to wind up at Warden container B because the host has routing rules that say anything targeted to the port where that application is actually running will get routed to the address .02. And so you don't have to worry about the traffic from any particular Warden container transiting directly to another container. It first has to go to the host.
Sounds more secure than before, John.
There really are additional layers in the onion, is the way to think about it. There's an additional feature which comes, I think it's in version 1.4, it might be version 1.5 of PCF, called application security groups. What this allows you to do is specify additional IP tables rules and bind those rules to a particular organization and space, right? So at the end of the day, you've got some default set of rules that control the network traffic within the cloud. At the same time, you might not be satisfied with that default set. Perhaps, for example, when you're running, you have to get connectivity to a particular backend database that's not hosted in the cloud. You can set up your IP tables rules as part of the application security group to say that I can get access to that IP address on another network because that's where I'm going to connect to my database. A different application running in a different organ space doesn't need access to that database. I can set up the IP tables rules to prevent that access. So I can lock things down a little bit better in the later releases. Also important to note about the staging and running. When you stage the application is when you're actually combining the source, the WAR file of the app is combined with the build pack. And in doing that process, you're downloading the bits of the build pack. They have to come from somewhere. Again, the rules for what you can reach out to and pull down from the network are different between the staging process and the running process. Because when staging, you need to do the build. You need to pull down those bits. But once you're running, you don't want the running process to have access to the build pack server, right? There's no need to do that. So you have a different set of rules between staging and running. Okay. Now we're going to talk a little bit more about cloud native. So the idea here is that we have this existing application, and we ran Fortress demo within Cloud Foundry environment, but as part of that, we wanted to get access to another service which is existing either in the cloud or somewhere else in your enterprise, while my Apache Fortress demo app is executing within Cloud Foundry. And I need to make a secure connection and present credentials and exchange data to render page 4, where that other application is something that is using more cloud native security, right? It's using capabilities like OAuth 2. Now, before we dive in and show the protocol exchanges, let's just ask the question, what does cloud native really mean, right? We've been talking about cloud native all week, and what does that actually mean when you're a security guy, right? If you're thinking about being a full stack security developer, where in the 12-factor app manifesto does the word security appear? Anybody? Have we read the 12-factor manifesto? Does the word security appear anywhere in that document? Not once. Absolutely not once. There's only 2 places in the entire thing where it even comes close to brushing past it and like peripherally possibly hinting at it. And that is in sections 3 and 4, it talks about config and backend services. And they make a mention that, well, you should get your credentials like somewhere dynamically. But it doesn't tell you how to do that, and it also doesn't tell you all the other implications of following these 12 factors, right? There's a lot to think about when the world becomes that dynamic.
It's tough being a security guy, John.
Yeah, just no rest for the weary at the end of the day. So 12-factor guidance is totally silent. It really is essentially silent, maybe not totally. It mentions the words credentials once, but security not once. At the end of the day, we got to read between the lines and figure out what are the implications for our security. And this beautiful static picture that we've given you, right? Here's this literally a fortress of security. And how does that change when I start doing this 12-factor thing? Okay, a couple of things you do take from the 12-factor app. You say HTTP everywhere, that's a given. And also that these microservices that you're intending to build and deploy are actually intended to be highly cohesive, small units of functionality, dedicated capabilities that can be recomposed, right? They're microservices. You have these things that are very tightly integrated so that they're highly cohesive in what they do, but they're loosely coupled to every other microservice. And the idea, the expectation is that we have the ability to do some sort of frequent recomposition, and we can say, oh, we've deployed it this way, but we're going to reuse that microservice someplace else, right? Someplace where it wasn't originally intended to be used, or maybe the requirements have changed and we've decided we need to change it up a bit. Everything in the picture is late bound, right? There's nothing static. So here's a direct access pattern. User at a browser wants to access these 3 different applications running in the cloud. The next day comes along, and all of a sudden we're saying to ourselves, oh, that center one, that could be Apache Fortress Demo, that's the entry point. And we're going to reach back and actually aggregate the data from those 2 back-end services, but present them in pages in the main app. Okay, change of plans. This other customer really likes the app on the left, and they use that as the entry point. So now I might be receiving requests from there, but the end user never authenticates to me. It's actually a man-in-the-middle situation. And then maybe in another scenario, in a quick redeployment, 6 months down the road, you want to say that now I am literally the man in the middle. I have requests coming to me where the browser interfaced with the app on the left. There's a propagation to me where I have to do some work. But to accomplish my use case, I've got to go connect to yet another thing, right? How do we do this? Not really possible when you're talking about static deployments. At the end of the day, it's a fabric. And you have to be willing to accept a couple of premises.
I'd call it something else.
You're just an old security guy. Bottom line is that you have to have this deployment agility with your security aspects too, right? Anticipate and expect that all of what we're talking about is dynamic binding for security. We have loose coupling between the services, and that implies late binding of your security services. And then finally, your code, the code that you're actually responsible to deliver for one of those little colored bubbles on the screen, that code might be asked to take on multiple security roles at some time or another. If not as part of one deployment at one time, further down the road at a different time, you might wind up having to fulfill a different role with that same deployed service.
We're not talking about RBAC roles here.
Yeah, good point, Shawn. We're not talking about RBAC roles, we're talking about architectural roles. For example, you are the relying party in this transaction, or you are the claimant. You're the guy who's actually asserting who you are, and you want to be able to gain data from another service. In this position, you're in a different role than you were when you were the receiver, right? So sender, receiver. You're in a different role within that transaction. The TLDR on this is that you're going to use OAuth 2, right? It's the only protocol that allows you to do this kind of composition. SAML2 is really important for identity federation. OAuth 2 is really important for authorization federation. And I'll use the word federation there, but it's essentially authorization in a dynamic, composed way. So why OAuth 2? I had to make a decision when doing this part of the talk of what we would focus on, because there's only so many hours in the day. There's only so many minutes that I can talk on this talk. So I have to whittle it down to what matters. I could talk about Spring Cloud Config. I could talk about a lot of other aspects. But I chose OAuth 2 because I kind of feel like this is the thing which is the single core competency. If you're a full stack security developer going forward in the year 2015, the one core competency you need to have is you need to be thoroughly familiar with OAuth 2. Not at the level of the APIs. It's great. You can always read the Java doc to learn the API. What I'm talking about is understanding the application of OAuth 2 and why was OAuth 2 created, and how do you recognize when the problem you're looking at can be solved by OAuth 2. There are message exchange patterns that occur, and I'll make the assertion that all of the message exchange patterns that need to happen, the naturally occurring things like the 92 naturally occurring elements, the 92 naturally occurring compositions that will occur with microservices, OAuth 2 can handle those. There's actually only 4, it's not 92, but you get the idea. It's a key part of Spring Cloud security, right? That's really the underpinning. There's lots of other stuff in there. But really, this is where you need to start. Expertise in OAuth 2 will make you a competent security person. So that leaves us with another problem. OAuth 2 is really hard to understand. right? The reality is that even people who are good at it and people who have implemented the stuff still get confused when you go through the protocol steps and you forget where you are, right? I'm going to try to offer you a different way to think about OAuth 2 so that when you're looking at those Java doc APIs, it actually clicks, that you'll have that light bulb epiphany that says, I can see through all of the clutter to understand from an architectural perspective why this stuff is here, okay? Hopefully we'll be able to get there. It's confusing because of that flexibility, and that comes from these grant types. 4 ways to run the protocol. We used to call this a profile, but it's essentially 4 ways to run through the OAuth 2 profile. You can do an authorization code grant, an implicit grant, a resource owner password grant, or a client credentials grant. And I can real quickly tell you, do not do that one, okay? Anti-pattern. It's in the spec because somebody wanted it there so that it would essentially standardize and bless bad behavior, right? We're already doing it in a bad way, and it really shouldn't be supported. And if the spec doesn't contain that, there'd be some sort of pressure, there'd be a social pressure to say, you gotta stop doing that. But resource owner password grant is in the spec, so it's technically okay to do it, but don't do it, okay? We'll get to why. Client credentials grant is the one that I'm going to talk about in more detail. That's the one that's interesting for the use case that matters to us, which is I've got an existing infrastructure, I've got traditional deployment and existing investment in apps, and I'm also doing cloud investment, right? I'm investing full hog in cloud native, but the other stuff is still there, right? And I need to interoperate with it. Okay. 4 architectural roles, not ANSI RBAC roles, but just your role in the protocol exchange. Are you the sender? Are you the receiver? These are the 4 roles that happen in OAuth 2. You're either a resource owner, you're a resource service, you're a client service, or you're an authorization service. And funny as it should occur, you can be more than one of these, right? One of the reasons this gets confusing is because you can actually be more than one at the same time. Pop quiz, what's missing from the picture? Can't wait too long because we're pressed for time. No authentication has been mentioned, right? Nowhere in this picture have I said you're going to authenticate. We assume that's going to happen. It's not in the OAuth 2 spec. It's not in the OAuth 2 protocol, okay? There's things in there that say the client must authenticate, of course, but it doesn't tell you how. It doesn't tell you anything about the details of what you need to do to meet the spec. You can do basic auth. You can do a certificate. None of that is in the spec. Okay, understanding OAuth 2 scopes. The last bit you need to understand before we fully dive in and look at the messages is that scopes are the basis of the authorization. There's some string that comes along with the authorization token that expresses what you're going to be able to do. It's a contract between the resource server that's going to receive and accept that and the client that's sending the token. But it's out of scope for everybody else. Not even the authorization server that mints the token cares what that scope means. It's utterly meaningless tag. It's just like tagging a blog posting. You can put whatever you want as long as the client and the resource server agree on it, right? To me, that's a little bit of an accident waiting to happen, but that's the way the spec is written because there's no way to nail that down in a way that could make everybody happy. Last thing before I move on is that the user can deny a scope. We're not going to do that in my demo because the user is not involved in the conversation, and I'm going to take you through these pretty quick. But the idea is keep in mind and pay attention to who's involved in the discussion, right, in the message exchange pattern, and keep in mind what roles are being fulfilled. So this is the authorization code grant. This is the typical one used for most consumer services and what you see used for SSO. So the user at the browser wants to go and connect to some application. They send the request. That application redirects the user through an HTTP redirect and goes to the authorization server and says, in order to do the thing you're asking me to do, you have to go get permission and grant me, as the client, permission. Go talk to the auth servers. Tell him it's okay for me to do this. The auth server and the user have a discussion. That's your approval page. And then the auth server redirects that user back and delivers to the client a one-time token, a one-time code that can be used to obtain an access token. Why is it a code and not a token directly? Because the code is passed through the browser, and it's something you don't want the user to be exposed to. So it's a confidential conversation between the auth server and the client, and it's transited through the browser. It's a code that no one can cache in that code except the client it was issued for. Client then caches in that code, gets a token back. Client can present that token. Resource server has to go check with his buddy to say, is this token actually any good? and there's some validation that's got to happen there. That can be offline or online. You can do that by way of a public key validation, or you can actually go and send the token to the auth server and say, did you actually issue this? Is it good? Answer comes back, it's a good token, I can give you the resource. And then the client actually does some work and returns the result to the end user at the browser.
Sounds simple.
That dance is going to happen in almost every three-party authorization or authentication protocol you see, but the details are going to be subtly different. The thing to take away, you can forget all of that animation. The thing to take away is the 2 bullet points in the lower corner, which says there's no mutual trust between the resource owner, the client, and the resource server. So when you're faced with a security problem and you're trying to figure out how to integrate this thing with that thing, you have to ask yourself that question. From a security architecture point of view, does anybody already trust each other, or is this a case of complete mutual distrust? If that's true, and by the way, the second point, that the resource owner is going to permit the client to go get a resource on their behalf, then this is the protocol run you need to do. Right? This is the one that solves that problem. So no mutual trust, and party A is going to do something on behalf of party B. Use this implementation. Use the authorization code grant. Client credentials grant. This one, again, looks a little similar, but there's a difference, and I'll flip through it. Same kind of exchange, goes back and forth. But what's different? In this picture, the user was not involved in the conversation, right? There was no redirect from the client through the browser back to the auth server, right? Didn't happen. There's no mutual trust between the client and the resource server, and the resource owner doesn't participate at all. It's not done on their behalf. Question in the back. I'm sorry, I can't hear you. You're going to have to speak up. Okay, the previous one? The authorization code grant, okay, so the question is, isn't the code exposed in the browser? We assume that you have network reachability to all of this stuff, right? Yeah, the auth server has to be reachable. Okay, and if I'm understanding the point, I think the point the gentleman is making is that the auth server has to be reachable, and it may or may not be executing in the cloud. That is possible. We assume that you have TCP and HTTP connectivity. Okay, so just before we jump off of that one, again, key point, resource owner doesn't participate, and the client gets access to the resource server on its own behalf, not on behalf of the user. Question in front. Right, so the question is, what about SSL? And the answer is that in many cases, you don't have SSL fully enabled everywhere. We'd like for that to be the case, but it's possible to have a compensating control. So if SSL isn't present, you can be using IPsec, for example, right? That's a perfectly viable alternative, and that gets configured at the level of the host when you deploy the VMs, and you don't actually have to worry about it at the application level. You'll get that same protection. Another point to make is that depending on where things are located, you might actually have SSL configured within a particular application but not another. But again, you can have mutual SSL, or you can have client doesn't have a certificate, server only authenticated. So different combinations can work. In that point, I'll try to answer it briefly by saying this. You're going to wind up looking at the details of the spec will say that you have to protect certain things at certain times. But in general, when you're using the Spring implementation, things will work out as long as you configure yourself correctly, right? And I'll get a little bit into the Spring config, but if it's configured correctly, you'll have appropriate protections on each exchange, because sensitive stuff has to go in the post, in the body of the post. You're not going to want sensitive stuff in the URL, in the get or the put. So those kinds of considerations are part of it, and that's why OAuth 2 gets complicated. Okay, implicit grant, real quickly. Lower right corner, again, that's the takeaway. I could run you through a mind-numbing number of exchanges again, but the answer is the takeaway in the lower right is why this particular grant type exists. And that scenario is when you would use this grant type. The client identity is not authenticated. The resource owner directly obtains a token for the client, and then passes it on to the resource server. The client is implicitly trusting the resource owner to not misuse his token. Okay? Those two security roles of client and resource owner are essentially collapsed, and the resource owner takes precedence. The client trusts the resource owner to do the right thing.
Sounds like a conflict of interest.
Resource owner credentials grant. This is the reverse. The resource owner trusts the client to do the right thing. And the resource owner is like you giving your password to the application, and the password handles the application handles your password in clear text, right? Bad idea, don't do it.
What's the example for the previous?
So the previous one, the implicit grant, this is actually done typically for a Java-based app, like a JavaScript application. So the entire application executing in your browser as JavaScript. And so that client application is in your browser, and it's making these connections. But you can't hide any of the transactions from the browser itself, because it's executing in the browser. Things like the token in transit or the client ID and password are in the browser, in the JavaScript. So as the user, I can see that stuff, right? This is the reverse case, the client on top of the resource owner. And in this case, it's like a mobile app. You've logged into your phone app, and you're putting your password into the mobile app. It's going to take that and send it, right? And the client application has your credentials. If the client application misbehaves, you're toast, right? So this is why I say, don't use this one, at least not as an enterprise integration pattern. You never want to do that. Okay, Spring Boot and Spring Security make it easy. I'm going to try to pick up some time here. Not going to go through all of the code details, but I will tell you that if you know these annotations, you can do most of what I've just talked about pretty easily, right? And hopefully what you get out of this talk is the fact that you know when to use which annotation, but the exact details, you're going to check the Java doc. So add enable resource server if you're the resource server. Put that annotation on your class, and magic happens. You'll have to write config, Java config, that populates the dependent beans that annotation is going to need. But it's pretty straightforward to do. Similarly for things like the enable authorization server or enable OAuth 2 client. Put that annotation on your class. You can behave as an OAuth client. Enable SSO is important to mention. It's there. I'm not going to talk about it, but it's a really cool, clever trick. Uses OAuth 2 as a way to transit an OpenID Connect transaction. And the resource they're gaining access to is your profile information at the place you authenticated. And so it's a way to accomplish an authentication and present your login session when you don't really have to think about authentication. Okay, resource server, you're going to implement a resource server configurer. Authorization server, you'll implement an authorization server configurer. The client is going to implement that add OAuth 2 client, and as part of that, you're going to work with an OAuth 2 REST template. Okay? I have a demo of a 3-party client credentials grant. Depending on how we're doing on time, we can over there or okay. A little bit of code. I won't bore you with the code. Question?
What do we call OAuth where shared secret is involved?
So there could be the question is, what do we call OAuth when there's a shared secret involved? Shared secrets can come in a couple of different places. Typically, things like the client itself might be a service that uses a shared secret for an ID and password to authenticate to, let's say, the authorization server. So there's a couple of places where there's a secret that's going to be configured in various places.
Is that a two-legged OAuth and three-legged OAuth?
Right, so the difference between two-legged and three-legged. The two-legged OAuth is the one that I was going to show you. If I'm understanding correctly, it's the client credentials grant. In that case, the authorization server and the resource server have been collapsed into one. In fact, I have that demo. There's code that'll be on GitHub that you can actually look at that. So both of those are run in the same process, and you're authorizing on behalf of yourself, right? You are your own authority. Okay, so let me run through this. Let me try to get the demo going. I'll do it as quickly as I can. Okay, and I'm going to put on my glasses so that I can actually read my screen. Okay, so real quickly, this OAuth 2 JPA thing, this is an application that I wrote. Another question, just to make this point, and then I'll really move on. Did the world really need yet another OAuth example? right? I mean, we've been through 2 days of the conference now. There's great examples out there done by guys like Dave Sire or Rob Winch. You know, you can make the list. Greg Turnquist, I guess. There's 3 or 4 good application examples out there from Spring. The reason I did this is because this one didn't exist.
Which one is this again?
So this is the client credentials grant with 2-party and 3-party. And as far as I know, and I did my search, when Shawn and I encountered this need, I looked for this example and couldn't find one. There are plenty of examples of the authorization code grant. There's the SSO example. There's all kinds of good stuff out there. Client credentials grant, 2-legged and 3-legged. I couldn't find an example of that I could make use of. And so I implemented it. This application here is Spring Boot, Spring Data, and Spring Security OAuth, so that it implements standalone as simple as I could. And you can use that kind of as a starting point if you have a similar situation. So basically, this is the backend server. This is a data server. And I have a client, and I've just actually got to check. OK, so I'm running on the branch with no UAA. So assuming that's what we wanted, UAA is not running, and I just run this app. So Spring Boot run. Now what this thing is doing is it's actually going to go, and it made a request. So pet store, got 3 records back from the pet store. And I'm going to show you in, actually I should have done this before. We go to Wireshark. Window. So I'm going to stop, clear, and we're going to capture, and then run the app again. So, completely anticlimactic. It's a small Spring Boot app that does a command line interaction to go and get some data from the database. But in doing that, it got an OAuth 2 token, presented that token, and got back the data because it was authorized. So let's go back and look at Wireshark. And you can see here there's a post, and the post happened to this OAuth token endpoint, and then a GET. And the GET presents that token as a way to get access to the service. It might be interesting to just look here and say, OK, the return from the post, you got back a JSON object, and that's the content, an access token, a token type, an expiry time, and the scope for the token. Now, what's interesting is if you look at that access token, let's see if we can get a look at that. OK, the access token, E59 ending in 2E. So then we'll do a look over here at the GET. And again, we have a GET request. Oops. And right here, authorization bearer token, E59 ending in 2E. So simple exchange, helpful to see it happen at the protocol level. But there's just the request and the request back. Last bit I'm going to do is to change this, and I hope to do this super quickly, is to say, flip over my Git branch. I'm going to say Git checkout. And say master.
So while you're doing that, you're going to engage UAA. What is UAA?
Right, so UAA, if you haven't heard, is the user authorization service for Cloud Foundry. It's a standalone project. You could use UAA without using Cloud Foundry. It's out there on GitHub. UAA is a great OAuth 2 server. And so I used it in this demo. Good to become familiar with it. If you are worried about security integration, UAA is your friend. So we'll check out master. And on this one, I will close and do another checkout. What's great about this is that I named my branches badly, and I keep forgetting which is which. But add UAA branch, and I run Spring Boot. Now we're going to run the UAA. So I've got these 3 windows. Basically, UAA process as the trusted third-party authorization server, and then on the other side, the JPA service, which is, again, the Spring Data, Spring Boot application, which is an OAuth 2 endpoint and is willing to accept a client credentials grant. Pay no attention to the build warnings. It's OK. No one is going to get hurt. OK, and I go back to the OAuth 2 client. And before I run that, I want to clear my Wireshark. So let's stop and clear. And we'll capture again, and then we'll run the app. Ugh, don't you hate that? It's always tough to stand and type. Not check out, we want to do run. Kernighan and Ritchie from C language fame one time made the remark, somebody said, can you give me any advice after your many years of experience in this industry, being a computer science genius? And basically, I think it was Dennis Ritchie who said, don't ever debug standing up. Right? That was the one thing he could offer. So you can see here, we've got the request. So similarly, HTTP request to get my OAuth token, this time going to the UAA, and then I was at 200 OK back from my token request, and then a GET, and I presented that token, and I got a 200 OK back. I'm going to save some time and not drill down through the whole Wireshark trace. You get the idea. The takeaway, I think, is check out the sample code on GitHub if this is something you think you need to do.
Everything we're showing you is in GitHub, and we'll have links at the end of the slide deck of how you can find it.
Okay. The other thing I'm going to show here, because I want to leave Shawn time for he can do his thing. We're getting short on time. OAuth 2 in a nutshell. I won't drag you through this table, but I think you should probably print it out and tack it on your wall. This kind of summarizes what we've done in the previous segment and say, here's how you know which grant type matters, which grant type you should use based on your existing assumptions. And then finally, kind of a comparison between a forklifted versus a cloud native app. And again, I'm not here talking about things like I used the Tomcat API or the particular Java servlet API that would be the current thing to do if you're writing this using Java 5 in an enterprise setting where you've got other constraints on you, versus I'm using Spring Boot and it's Java 8 and it's the coolest, slickest thing. That's not what this is about. It's not about APIs. It's about security properties. From an architecture perspective, when you look at things like what attribute does the application have? Is the application's role in the security interaction something which is singular and invariant? Or is the application's role in this conversation considering that it has multiple security roles to fulfill, and those roles are made explicitly at deployment time and it's configurable, right? That's how you distinguish sort of traditional from cloud native. Things like my authorization policy enforcement point is expected to be the container, or is it expected to be Spring, right? Is my policy enforcement point container-based? Is it the Tomcat container that's doing that? Or is it the Spring infrastructure that's part of my application, right? This table kind of summarizes from an architectural overview where things are going to be different. Okay, segue into SAML2. I'm going to give Shawn some time to talk about SAML. At the end of the day, OAuth 2 is great, but SAML is the thing you need to do enterprise federated SSO. So we're going to talk about that. And the important thing to understand here is that this is useful when the identity provider is coming from a different trust domain. Your identity provider is not being used. Somebody else is issuing the identity, and you're inbound. You're a relying party to that asserted identity. The organizations are doing provisioning at the organizational level. It's not user self-provisioning like it might be with OAuth 2, but it's organizational level agreement to do a federation, and you're getting an inbound SAML assertion. How do you make use of that in your app? It's a skill that you want to have when you're a full stack security developer. So with that, over to Shawn.
Thanks, John. We're down to the wire. We just really have a few minutes left, so I'm just going to rush through this last bit. Okay, so we're back to yet another tutorial, and this is the last one. So this is called the Apache Fortress SAML demo, and again, this is available online, the full procedures in doing it. If you just follow the steps, I'm just going to give you a conceptual idea and jump through it real quick. So we're going to use SAML instead of container auth. What has that done to our 5 security layers? Well, we've lost one. So we don't have Java EE security anymore. We're going to cross that out. We've moved the deadbolt 1 layer down into Spring security. The other 2 layers remain the same. So the areas of access control have not changed from the first demo that I gave you. We were still using Tomcat. So now the first thing that we're going to have to do in order to use the Spring SAML, or really any SAML, is we need to generate metadata for the service provider. And so how I did that for this demo is by downloading one of these two projects. And so I don't know if anybody's ever used the Spring SAML sample. That's the first place you want to go if you're interested in doing SAML development inside of a Java app. Okay, you go there first, and then after you've figured that out, if you want to come back and figure out how to do RBAC in there, then come look at this one. Okay, and then the second one, the shibboleth sample, that's a Unicon sample that's derived on the Spring sample, and that's more about if you want to hook it into a shibboleth IDP. So either one of these are just perfectly good first places to go. But for this particular demo, we're using one of those to be the service provider metadata generator. So you're going to download and build that app, and you're going to deploy it, and then you're going to hit a page with your browser. It's going to bring up a form, and you're going to enter some tags in a form. And the takeaway for this slide is right here, this entity-based URL right there. You better know that before you get to this step, because it's got to match the URL of your application exactly for the SAML authentication to succeed. So if you're using TLS, you're going to specify it there at this point in time when you generate that metadata. Okay, so once you've got that metadata on the service provider generated, the next thing you're going to do is set up a global identity repository. And this is basically, in SAML parlance, this is the identity provider or the IDP. For this example, we wanted to sidestep the complexities of setting up a separate IDP like shibboleth, because that's a whole nother talk, that's a whole nother can of worms. So for this particular talk, we're just using a well-known public IDP called SSO Circle, and it is basically SAML as a service. And so in order to do this tutorial, you'll just set up an account with them, and it's really easy to do. And then once you've got that account set up, we're going to import the service provider metadata that we did in step 1 into a form on that global IDP. And so that's just really easy to do. I mean, you can just follow the steps in the tutorial. And so once we've done that, we've got to figure out how we're going to do the mapping between the two accounts, because we've got a global repository and we've got a local repository for our service provider. And so we've got to figure out how we're going to link those two accounts. And so for this tutorial, I elected to use the surname field on the global IDP, ssocircle.com, as the attribute that gets mapped in the SAML assertion when it comes down to the service provider of the application. And so what that really means is the SAML assertion that's generated during the authentication step contains the value of that last name field in the assertion itself. And so when that assertion makes it to the application, and if it validates correctly, the application will parse that. It'll grab that attribute and it will use that as the user ID in the application. Does that make sense? Well, in this case, I just chose the last name arbitrarily. So it's just a container. So I mean, we're just playing around, right? Okay. So we've got the IDP set up. We've done the mapping. The next thing we need to do is we need to tell the service provider who the IDP is. Okay, so we've already told the IDP who the service provider is in the second step. Now we're going to do the opposite. And so we're using Spring SAML. We're back to the Spring context file. And so there's just a declarative that you put in there, and you put a URL in there, and it's just that simple. Okay, so now we're going to enable SAML authentication using Spring. Again, we're back to the Maven file. We're going to drop a couple more dependencies in our POM file to tell it to pull down the Spring Security SAML dependencies. And then we're going to go back to the context, and we're going to enable the SAML authentication filter. And it's really just that easy, okay? And then, so once we've done that, now we're back to this RBAC thing. Well, that really hasn't changed, okay? That's still sitting there. And so we still have to tell the application to use RBAC, so we've got a dependency we got to drop in our POM. So, you know, we dropped the Fortress dependency in there. And then we do have a slightly different identity propagation than I did in the first example. So in the first example, the container was doing the authentication and we were pushing the principal down. Now the Spring SAML runtime is doing the authentication, and so the application is going to get the principal from Spring SAML, and it's going to then parse that and get that surname field that I was telling you out of there, and use that to call Fortress to create a session. Okay, and it's going to set the trusted flag to true because we don't have a password. Once we've done that, we push the session we push the RBAC session into the HTTP session, and everything else is the same. All right, so I've got this damn demo. It's late. And there's 4 users, 3 pages. Sam Star has access to all 3 pages. Sam1 has page 1, Sam2 has page 2, Sam3 has page 3. And so I'm just going to real quick log in just to show you that it works, because I think we are out of time.
Yeah.
And so when I go to the URL to the application immediately realizes I don't have a cookie. It redirects me back to the IDP. In this case, it's ssocircle.com. And so then I need to log in with my global credentials. And so I'm going to log in with my global credentials. And this is a public IDP, and so I guess they get spammed or they got bots, so they want me to prove that I'm not a robot. And I really love this step, especially when you got to do it 1,000 times to test. But, so it's got to tell me to look at the cars, which I actually like this one. It's better than the donuts. And so I do that. And then, so now after proving I'm not a bot, it's going to redirect me back to the SP. The SP got the SAML assertion, like I said. It pulled out the user ID. In this case, it was Sam Star. Sam Star has access to all 3 pages, and there the links are to all 3 pages. So that's it. I could go back and show you. I could go log back into the global IDP and set a different value in the surname field just to prove to you that another user, like I could put Sam1 in there, and then it would come back here and you just have the link for Sam1. We don't have time for that, but if you want to try that, that's,
yeah.
And obviously this is a contrived example, but the point is just to show you how to use it in your app.
Yeah, but there's a couple of important takeaways. You can try this at home, and you should. We have the code out there. SSO Circle gives you a chance to do that relatively easily. At the same time, keep in mind that the one kind of technical takeaway that really was clever and important, and Shawn went over it very quickly, was just the propagation of that identity. So in came this assertion, and now I have an ANSI RBAC session that I can actually track things like separation of duties on an identity that was issued to me from somewhere else. So that's like a really important security integration technique that you should have in your back pocket.
Yeah. So here's the field that I was talking about in the profile that you would just change that to another, and then you log in again. So obviously this is just for testing. This is not a real world. So that's it for that demo. Again, you can go back to this slide, click on the link, pull it down, try it out if you're interested. Okay, I think we're
out of time. So wrapping up, if anybody has any questions, we'll take questions. Otherwise, I'll say check out the last 2 slides of the presentation. We tried to list the sage advice that we would offer for people who are dealing security integration, dealing with this. Assume your trust relationships are dynamic. Expect to fulfill multiple security roles. Beware of unexpected SOD violations, and use ANSI RBAC where you can. Beware of unwanted transit of trust, because that can happen when things are that dynamic. Always enable inbound user identity propagation, and avoid outbound identity user propagation unless the user has the opportunity for opt-in and the ability to self-provision at the target. Use TLS everywhere you can, and always remember defense in depth still applies. At the end of the day, we want to be cloud native, but in the meantime, we have to interoperate in this heterogeneous world where we're still supporting the traditional infrastructure that's already been deployed. So thanks very much.
Thanks a lot.